Hi, we will discuss the partial fraction technique in this video. In overall, if you have a rational function like this, let's say your rational function to be equal to numerator divided by denominator. So for example, let's say you have something like 1 over 5x plus 1, where you should know that 5 plus 1 is a linear factor. So x minus 1 square is the linear factor with repeated, right? Or you can call it a repeated linear factor, x minus 1 power 2. Or you may have x plus 1 power 3, which is linear factor also. Therefore, it can be power of k. So next, let's say you have quadratic factor. So this quadratic factor cannot be further reduced to linear factor, because if you check the root for this, you will be in complex number. So let's say this is the case, quadratic factor, where b squared minus 4ac for this case, your b is 1 here. So a is 1, c is 2. So minus 4, 1 multiplied with 2. So in this case, you get negative number. So if you have something in negative number which is less than 0, we cannot reduce it further to linear factor. So this is the simpler form that we have here. And for the last case, is a repeated quadratic factor, where you can see there is a k here. So this case is repeated. So for example, your x squared plus x plus 3. But in this case, there is a repeated quadratic factor here. So for this problem, okay, we want to simplify this further, we can use the partial fraction. So this term can be equal to, let me write it here. So 5x plus 1 is a linear factor, so you refer to the first case, so equal to 5x plus 1. Okay, so the linear factor, okay, at the top, a actually is the unknown constant, so this is the constant that you are looking for, a. So we continue, we look at the second factor, which is x minus 1 square. So in this case, it's a repeated factor. So in this case, where the k is 2, so we have to use this, where you have x minus 1 plus x minus 1 square. So we have a constant a1, a2 here. Let's say we have a constant b and constant c that you have to solve. So x plus 1 power of 3 using the same method. So you have x plus 1 plus x plus 1, increase the order to 2, plus x plus 1 power of 3. Right, so the constant d, e, f. So you can see that for linear factor case, the unknown at top is the constant. Next, we move to quadratic case, which is these two cases. One is non-repeated, another one is repeated. So for non-repeated, for this one, So you can write it here, x squared plus x plus 2 here. So at the top here, you can see that is a linear factor. So you have a EF, G, X plus H. So the unknown is G and H that you are going to solve, which is these two unknowns. Lastly, for x squared plus x plus 3 here, so since it's repeated, so you start from this one, ix plus j. So I and j are the unknown, okay, that you are going to find, which is these two unknowns. And it's a power of 2, then you have to continue. I continue here, you have to add with kx plus l. So your k and l is unknown a2, b2 here. So you divide it by x squared plus x plus 3 power of 3, 2, sorry. So because this is power of 2. Right? So this term, by using partial fraction, we success to convert into this form. And your task is to find the unknown a to l here. And if you're able to do this, you master the skill for the partial fraction. Let's start with the first case. So this is the rational function. You have n nominator divided by d denominator. As we mentioned before, all of this is linear factor. So if you have k number of linear factor, then you have to separate 1, 2 until k term. So this is partial fraction decomposition. The process of converting this form to the right hand side, so this process is called the partial fraction, right? And the result, okay, that you get at the right hand side, we call it as partial fraction decomposition. So you can say that this result is called the decomposition part, and then the process of converting is called the partial fraction. So these are the terms that we use. You should be able to obtain this partial fraction decomposition from the left hand side. Firstly, you check all of this is linear factor. Second, you have to check whether this is proper or improper. So at the top, the degree is 2. At the bottom, x, 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 you have 3x. The highest degree is 3. So in this case, is improper. And it cannot be further reduced, right, by using the factoring. So for the first linear factor, x, at the top is a constant a1, plus with the second linear factor, 2x minus 1, at the top you have a constant a2. Lastly is a linear factor x plus 2, and with the constant a3. To find the a1, a2 and a3, so let's multiply both sides with the denominator here. So multiply with x and 2x plus 1 minus 1, and then multiply with x plus 2, right? So you multiply everything with the term here, then you should be able to get this. So this term should be cancelled off. a1, x cancel off, you only have 2x minus 1 and x plus 2. a2 here, 2x minus 1 is cancelled off, you only have x and x plus 2. Lastly, a3, okay, x plus 2 is cancelled off, you only have these two terms. So you collect the term for x squared, x, and then you can compare both sides. For x squared, this term is equal to 1 here. Second term here is equal to 2. And lastly, negative 2a1 is equal to negative 1. So we can compare it, and then from here you can solve it. So you can see that a1 here you can obtain a1 is equal to 1 over 2. So you can substitute here. So a1 should be equal to 1 over 2. So therefore you get 1 over 2x, which is this result. So a1 you get 1 over 2, you can substitute here. Then two equations, two unknown, you can solve the a2 and a3 here. So after you solve it, you substitute inside this formula, then you should be able to obtain the remaining term. So we move to the second case, linear factor. In this case, the linear factor is repeated, where you can see this term is a linear factor ax plus b and is repeated. The order is 2. So in this case, so let's say we have a 4x divided by x minus 1 power of 2 multiplied with x plus 1. So this is linear factor. This is repeated linear factor. So repeated linear factor. This one is linear factor. So we start with the linear factor term. On your right hand side, the partial fraction decomposition form, it should be in this, where you have a constant a1 at the top. Sorry for that. So we start with the linear factor, where s plus 1 you should have a partial fraction decomposition here, x plus 1 with constant a3. Then for the repeated linear factor is power of 2, therefore you have a x minus 1 power of 2, x minus 1 power of 2 here, and top you should have a constant a1 and a2. So this is your partial fraction. Then you multiply both sides with the denominator here, right? You multiply with this. So this will be cancelled off at the left. And on the right side, okay, this is what you should have. So x minus 1 multiply x minus 1 square x plus 1. So this one, x minus 1 multiply this, you should get x minus 1 to the power of 1 here, x plus 1. a2, okay, you have x minus 1 square, you multiply with this, you should get x plus 1 only. Lastly, a3 divided by x plus 1, multiply this, cancel off, you get x minus 1 power of 2. That's it. We can rearrange the term here for x square, x, and the constant. So by comparing the coefficient, x squared on the left is 0, 0x squared, you get 0. So 0 is equal to your a1 plus a3. So we form the first equation. Second, we compare the x, a2 minus 2a3 to be equal to your 4 here. So x, a2 minus 2a3 to be equal to your, this will be 4. And lastly, minus a1 plus a2 plus a3 to be equal to 0 here. So from here, we can form 3 equations and then to solve 3 unknowns. By solving this, you should be able to obtain your a1 equal to 1, a2 equal to 2, a3 equal to negative 1. Let's check if this is correct. So a1 is 1, a3 is negative 1. So 1 minus negative 1, the first equation is correct. Second equation, a2 is 2, a3 is negative 1. So you have a negative 2, negative 1, plus 2, 2 plus 2 becomes 4. That is correct. Lastly, you have negative 1 plus 2 minus 1, which is 0. That is correct as well. So this is partial fraction for the linear factor case. Let's move to the next case. So we have the quadratic factor case here. So for case 3 is non-repeated. For case 4 you will have repeated quadratic factors. So in general you can see that you have a rational function where you have the quadratic factor. Quadratic factor example is given here, where you can not further reduce it into linear factor because the root is complex. So when we perform the partial fraction, we can see that for the quadratic factor, at the top there, okay, you have a linear factor which is ax plus b. A and b are the unknown constant. For the linear factor, we use the previous method where we have a constant a2 here. So to solve this, same thing, same approach, we multiply the denominator for this part. Okay, we multiply both sides for this part. So on the left hand side, whole thing here will be cancelled. On the right hand side, this thing will be cancelled. Then you multiply with x plus 1 here. And this term, this will be cancelled. You multiply with 4x squared minus 4x plus 3. Right? With that, you should be able to obtain this. And then you collect the term for x squared, x, and the constant, which is the x power of 0. Comparing both sides, for x squared, you get 0 here. So therefore, your a1, 4, a3, there are some typo here, so I have corrected. This should read the a2. So a1 plus 4a2 should be equal to 0, okay, which is the first equation. Second equation, b squared minus 4a2 plus a1 should be equal to 1 here, because for your x, the constant is 1, which is the second equation here. Lastly, b2 plus 3a2 will be equal to your negative 1. This is your third equation. By solving these three equations, your a1, a2, and b2, this constant can be found. So you should get your a1 in this case to be 8 over 11. Therefore, you can see 8 over 11 constant here. Your b2, you should get negative 5 over 11. And your a2 should be negative 2 over 11. So this is your partial fraction result. And next, if you have a repeated quadratic factor, where you see for this term is in power of 2, so which is this term, right? So this is linear factor, and this is repeated repeated quadratic factor, because it's power of 2 here. So we can separate the linear factor. At the top is the constant a1. For quadratic, so beside having x squared plus 1 square here, so for the repeated, you have to start from x squared plus 1, continue up to the x squared plus 1 power 2. So you have two terms due to the repeated quadratic factor. So at the top you have a plus b. So this is constant a2, b2 is not same with the a3, b3 here. Same by multiply both sides with the denominator here. So this term can be cancelled, you get this. And multiply at the right hand side here, a1, you will have this constant, x gone, right? So multiply here, you get x, multiply with x squared plus 1. And then on last term, multiply it, you cancel off this term, and then you have the x factor only. So rearrange the term, okay, according to x power 4, 3, 2, 1, and 0. Then compare the coefficient. So a1, a2 equal to negative 1, x power 4, you don't have x power 4, Therefore, it should be 0 here. So this is your first equation. So b2 is x power 3. So x power 3 here you have -1. So this is your second equation. So you have 2 here, and this is equal to 2. So this is your third equation. b2 plus b3 will be equal to -1 here. Lastly, a1 should be equal to 1 here. So by solving these 5 equations, you should get the 3 unknown. So the first unknown a1 you get 1, a2 you get it should be 5 unknown, right? Because a you have 3 unknown, b you have 2 unknown. So a2 you should get -1 here. This is -1, and b2 you should get -1 as well. Here you should get -1 because the negative multiply inside, right? So a3 you should get 1, and b3 you should get 0 here, right? 0. Okay, so this is your partial fraction result. So let's look back the linear factor case. So far I've shown you the general approach to find the unknown a1, a2, a3. So there is another alternative. If you success to form this equation, so you found that when you let x equal to 0, these two terms can be cancelled when you substitute 0. We substitute 0 here and 0 here. On the left hand side you get -1. On the right hand side, this term cancel, you get -1, -a1 there. 0 multiply plus 2, you get 2 here, multiply with 2. -a1, 2. So on the other hand, to find the a1, -1 divided by -2, you get 1 over 2, which is exactly the same answer here, right? So it means if you want to find the a1, let the x equal to 0, then you can find the a1, 1 over 2. To find the a2, let the x equal to 1 over 2, right? You substitute inside both sides, then you should be able to find the a2, which is equal to 1 over 5. Lastly, for a3, you substitute x equal to -2 based on this factor. So once you substitute, you should get your a3 equal to -1 over 10. So this is another alternative to find the constant instead of derive. So both methods are acceptable in this study. This alternative can be applied to other cases as well. Let's try with the case 2. So we have 3 unknown a1, a2 and a3 here. To find this unknown, instead of performing the derivation here, what we can do, we can substitute x equal to some number. So the easiest one, we choose 1 because this term can become cancelled, become 0 here. X minus 1 is 0. So you only have x equal to 1 here. You have 2a2 here, which is equal to, on the left hand side, 4 multiplied by 1, you get 4. So your a2 is equal to 4 divided by 2. So you get the a2 equal to 2. So we can substitute inside a2 equal to 2 here. You get 2 over x minus 1 power of 2. So which is this term. And you can continue. Let the x equal to, let's say in this case, let it to be 0. It should be -1. So this one, you substitute this term, cancel 0, and then this term also cancel 0. So when you substitute -1 here, you get -2. -2 power of 2, you get 4. So 4a3 equal to, on the left hand side, you have -4. So that means your A3 is equal to negative 4 divided by 4, which is negative 1. So if you compare, it's the same with the result that you obtained earlier. So for the repeated case, if you choose x equal to 1 and negative 1, you can cancel off the factor easily and directly get the A2 and A3. To find the A1, you can substitute x to be any number. To make it easy for the calculation, you can let x equal to 0. So on the left hand side, 4 multiply x, you get 0. A1, okay, you substitute 0, you get negative 1. You substitute 0 here, you get 1. Continue with A2. Okay, 0 here, you get 1. 1 multiply A2, you still get A2. 0 here, negative 1, power of 2, you get 1. Then multiply A3, you get A3 here. So A2 and A3, you already obtained it to be 2 and negative 1. So we can substitute 2 and negative 1 here. So you get 1 on this term. And then this one you multiply, you get negative A1. So negative A1 plus 1 here. So to get A1, you can be easily calculate it to be 1. Right? So negative 1 plus 1, you get 0. So therefore, you get your A1 equal to 1. So these are the alternatives to find the constant. With that, we have completed the discussion about partial fraction. So now you should be able to perform the partial fraction. Let's continue by solving the integration involving the partial fraction. So let's say we have a problem like this. So we have a rational function here. So let's say we want to use the partial fraction. First thing, you have to factor in this component. So by using the factoring technique, the denominator can be further reduced to linear factor and quadratic factor. This can be easily done by taking out the x. Then you have this. So we further check the quadratic factor, see if it can be further reduced to linear factor. Yes, it can be done. The way to check it, okay, you can check it by using b squared minus 4ac, or you can use calculator directly find the root. So in this case, you get the root to be x equal to negative 2 and x equal to 102. So therefore, this term, it can be written into 2x minus 1, where your x is equal to 102, and you have a x plus 2 there, right? So initially, this problem here, after performing the factoring technique, we are able to convert into this form. So from this form, you have 3 linear factors, 1, 2, 3, and you want to solve the constant a, b, and c. So by using the partial fraction technique, where you let x equal to 0, you should be able to get your a equal to 102. Okay, where you should get this x squared plus 2x minus 1. Multiply both sides with this denominator, you can cancel it off, right? It should be equal to a. So we multiply both sides, the x term can be cancelled off, you only have 2x minus 1 x plus 2. So plus b, 2x minus 1 cancel off, you only have x and x plus 2. And lastly, your c, okay, you only have the x and also the x plus 2. Right? So we substitute x equal to 0 inside. This can be cancelled off. You only have -1. So 2 multiplied 0, you have -1 here. 0 substitute, you have -1 multiply 2, you have -2a. And if you substitute x equal to 0 to this term, cancel off. This term also cancel off. So easily you can find your a equal to 1/2, which is this. Right? So you can, using the same approach, let x equal to, for this case, 1/2. Then you can find the b. For this case, you choose x equal to -2. Then you can find the c as well. So your BC, go to practice, you should get this answer. So once you get this answer, you should substitute this. And you can see that you can solve this easily by using the basic integration rule. For 1/u, you get ln u. So 1/2x, you should get 1/2 ln x. 1/5 divided by 2x minus 1, you should have 1/5 ln 2x minus 1. And lastly, -1/10 divided by x plus 2. After integration, you should get this as well. Be careful that if you divide it to be 2x minus 1, you have this 2x, you have to differentiate this term, then you have to divide by 2. So this should be changed to 1/10. So you should get this answer, 1 divided by 10 multiplied ln 2x minus 1. So you can check, to avoid this mistake, you can always use a substitution to solve this problem. Let's say you have this problem initially. So we can use substitution, let u equal to 2x minus 1. So your du will be equal to 2 dx, and your dx is equal to du/2. So we can substitute. 1/5 can be taken out. 1/u. So your du is du/2. Dx equal to du/2. And we can bring the 2 outside. So it becomes 1/10 here. So integrate 1/u du by using this formula, we can obtain ln u plus the constant c. So u you substitute back, it will be 2x minus 1 here. So you should get this answer. So please correct this. This should be 1/10. Let's continue to solve the example 2. So in this case, the integrand is rational function as well. And if you check, the degree at the top here is 4 and the degree is 3 at the bottom. So in this case, we can further reduce it. By applying the long division, we're able to reduce the improper rational function into proper type. So this is the procedure where the top, we put it inside here and then divided by the factor here. So firstly we multiply with x, you get this, and then you minus the whole term here, then you should be able to get this. So x power of 3, you have to multiply 1 here, 1 multiply x power of 3, again this term, and then continue multiply the other, then you get this. So once you minus it, you get the 4x as your remainder. And we can write it to be x plus 1 here plus the remainder 4x right here divided by the factor. So in this case, you can see that the degree at the bottom is higher than the one at the top. So this is proper type. So for the x function, if you integrate, you can easily get the answer x squared over 2. Integrate 1, you get x. So for this part, this requires the partial fraction. So first of all, we have to factorize this polynomial. So we continue to factorize the denominator, which is this component. So this component, if we take out the x squared, so we can have x minus 1. If you multiply back, you get x power 3 minus x2 minus x plus 1. Okay. So if you take out the bracket here, so you multiply this inside, you should get back this term. So we able to form x minus 1 at both sides, so we can take it out. So this is our x minus 1. The remaining is x squared minus 1, which is this term. And we check, okay, this x squared minus 1 is x plus 1 multiplied with x minus 1. So x minus 1 multiply x minus 1, you get x minus 1 power 2. So this is repeated linear factor and this is linear factor. So you can use the derivation to rearrange it, and then just see you can get this. There's another method to do the factoring. So let's say you have this. So by using the calculator, you can easily get the root where the x equal to negative 1 and 1. So x to the power of 3, you should know that there are 3 roots, so that means one of them is repeated. So from this root we can find the factor. So the factor should be x plus 1 for the root minus 1, and the factor should be x minus 1 for the root x equal to 1. So from here, okay, when you expand, you should get this x squared minus 1. So these are the two factors. So to find the remaining factor, we can take the x power 3 term inside here, and we perform the long division. So you divide x plus 1 and divide x minus 1, you should be able to get the last factor. So in simple, we directly divide the x squared minus 1. So we have to multiply x here, you get x power 3, x multiply negative 1, you get negative x. So when we minus this part and this part get 0, this one remain, and 1 remain here, plus 1 at the end. So this one you have to minus with 1, 1 multiply this, you get negative x squared, minus minus you get positive 1. So the remainder is 0, indicate that x minus 1 is also a factor. So you multiply x minus 1, so these are the factor here. So you can see you have x plus 1 is the linear factor, this term, and x minus 1 square, which is the repeated linear factor, this and this. Right? So this is another alternative that you use to find the factor. So once you solve the factoring and get the answer, you can substitute inside this integration. Then you should be able to get this. Okay, we substitute the factoring, you get this. So we can perform the partial fraction decomposition, where x plus 1 you have it here, x minus 1, and power of 2 repeated, you have to repeat 2 times. So which is one is x minus 1, another one is x minus 1 power of 2. So at the top we have a constant a, b, c here. So let's say you don't know this constant a, b, and c. So same approach to find the a. Okay, the easiest way you let it x equal to negative 1. So you substitute negative 1 inside, So 4 multiply -1, so which is your 4x, right? So the denominator you multiply to the both sides, this part will be cancelled, and then on the right hand side you get your a, multiply with this you get x minus 1 square only, plus your constant b unknown, x minus 1 you multiply with this, right? So it can be cancelled off, you get x plus 1 and x minus 1, and lastly plus c, so multiply with it you get x plus 1 only. So we substitute the x equal to -1, continue, on your right hand side you get your a, -1, -1, -2, of 2 you get 4. So with that you're able to get your a equal to -1. And the rest, once you substitute -1 plus 1 here will be 0. So this one will be 0 as well. So this is your final answer. So in this example, you can let x equal to, so for the second case here, let x equal to 1, then let x equal to 0, you should be able to find b and c constant. We have a problem here where initially it's improper, and you should master the technique to convert it to the proper rational function. So for this term, you further use the factoring, and then you use the partial fraction to separate out. In this form, we can use the basic integration rule to solve this, right? So x, this is polynomial, you can get x squared over 2. Constant, you get x. -1, x plus 1, you get the term in ln. This one also the term in ln. This is polynomial, so this will be x minus 1. Okay, bring it up, you get 2x minus 1 power of -2. So you can integrate this dx. So at the top plus 1, so at the bottom you have to minus 2 plus 1, you get -1 here. So rearrange this, right? So this is your integration result. Rearrange this, you should get -2 over x minus 1. -1 is x divided by x minus 1. So this is your final answer. So if you stop here, it should be okay. But most of the book, it will simplify it. So rearrange the term, you should be able to get this as well. Let's try more examples here. So for this problem, we have a rational function. So we check this problem is improper, right? Why? Because the degree is the same, where we can further reduce it by using the long division. So by applying the long division, you should be able to convert it into this form. So in this form, we have a proper rational function, because for this part you can see the degree is 2 at the bottom, this is 1 here, right? So you should master the long division and then able to solve this. So please try it. So we can integrate the 1 first. Okay, integrate 1 dx, you get your x answer, and we continue with this part. Let's continue to apply the integration method to solve this. So you can see there's the x power of 2x. If you differentiate this, you get x plus a constant here. So probably we can use substitution to solve this. How about integration by part? So integration by part is not stable because there are no two products, right? So in this case, normal substitution, maybe integration by part is not stable. So let's try with substitution. So we let u equal to the term at the bottom, differentiate it, and then we substitute inside, right? So we get this. So you see that we cannot convert the x into u, so substitution is not working in this case. So we have to find a way to integrate this. So the method that you learn, you can use partial fraction as well, right? So to do partial fraction, this term must be factoring. You have to factor out this term. So to get something like linear factor, s plus a, s plus b. So you can quickly check the calculator, what is the root. So in this case, you found the root is in complex number. So when you get complex number, it means that you don't have linear factor. The factor is in quadratic. So this is already in quadratic form, ax squared plus bx plus c. Therefore, this cannot be further reduced. So in this case, we are applying the factoring and we found that we cannot further reduce using the factoring. You still have one technique to further reduce it to linear factor format. So what is it? Okay, it is completing the square. So let us try to solve this by using completing the square. Please recall how to do this. So from here, you take out the constant for only for the term x. Then apply the formula. You want to get something in square here. So this one minus 1, you have to divide it by 2. And then you have to minus this term inside. 1 over 2, power of 2. Then plus 3 remains. So I put it in front here, plus 3. So you multiply inside, you should get 4x minus 1 over 2 squared. So here you get 1 over 4. 4 multiply negative 1 over 4, you get negative 1. So negative 1 plus 3 here, you get plus 2. So this is your result after you perform the completing the square, right? You should get this. So we have shown you that the factoring is not applicable. It cannot further reduce because the root is complex number. So the most simplest form is in quadratic. So we try the completing the square. So previously from here, we try the completing the square. We're able to obtain this. So you check it. It should be the same answer with this, right? So this means that when you substitute inside, you can let your u equal to x minus 1 over 2, right? By using the substitution, you can solve this problem. Or you can further simplify this and then, okay, since the 4 is 2 power of 2, so you can multiply inside. So 2 multiply x, you get 2x here. 2 multiply 1 over 2, you get 1 here. So in this case, you can let your substitution u equal to 2x minus 1. So both, okay, also applicable. So in this case, we choose this one. So this is what we have performed so far. This is proper form, improper, sorry. So we convert to proper. So this is improper. Then from this form, we convert here by integrate this. And then from here, we perform the completing the square. So now we are here and we suggest we can let u equal to 2x minus 1 to solve this problem. So your du should be equal to 2 dx and your dx should be equal to du over 2. So this is our substitution. Let's substitute inside this formula. So this term is u, true remain, dx become du over x, right? So what is your x? From here you can find your x. Your x is equal to u plus 1 divided by 2. So I can substitute the x here, right? Minus 1 remain. So let's further simplify this. You see that is a proper form, and u squared plus 2, you try to find out whether we can further reduce. Since this is a complex number, the root u is a complex number, so we cannot further reduce it by using factoring, right? So let's expand this, okay, u over u squared plus 2. So if you differentiate this, you get u. So we can use substitution to solve this. And for this problem, it's in the format of a squared plus b squared. So we can use the triangle substitution, where for this case, your u is equal to a. So a squared is 2, so your a is square root 2 tangent angle, right? So let's try with left integral first, where we can apply the basic integration rule. So if the denominator at the top is derivative, you get ln d. So in this case, if you have integrate u squared plus 2, and at the top is the derivative of this, which is 2u du, then you should be able to get equal to ln u squared plus 2, right? So since this case you only have u, so you have to multiply this whole thing with 1 over 2. 1 over 2. So this is your answer. So therefore you get 1 over 2 ln u squared plus 2, which is exactly the same with theta. So don't forget your 1 over 4, you multiply inside, so you get the answer for this term. So we have successfully solved this part. So this is the answer. Let's continue with the second part here. So how about if you integrate 1 over u squared plus 2 du. So in this case, we say that we substitute your u equal to your a is square root 2 tangent angle. So your du will be equal to square root 2 tangent, you differentiate, you get secant square angle, e angle. So let's substitute inside here. You get 1 over, so square root 2 power of 2, you get 2. Tangent angle power of 2, you get tangent square angle plus 2. So du is square root 2 secant square e angle. So you should know that tangent square angle plus 1 is equal to secant square angle. So where this term you can take it out, 2 you take it out, this one become 1. So this whole term here, you can further reduce it to secant square. So this and this can be cancelled off, and square root of 2 divided by 2, you get square root 2 here, right? Square root of 2 divided by 2, you get 1 over square root 2. So these are the answer. So we further solve this, you should get 1 over square root 2 and in the angle. So what is your angle? So your angle is this, right? So we can back substitute 1 over square root 2. So angle here we substitute, you should get u over square root of 2 and then a tangent And don't forget your constant plus c here. So this is our answer for the right integral here. So you have minus this thing and multiply with 1 over 4. So you should multiply 1 over 4. Okay, 1 over 4 here. So 1 over 4 multiply this thing and then take the minus. Right? So you compare, you should get the same answer here. So there's another alternative for this problem. Okay, you can rearrange it where we can apply this formula directly. But most of the time we cannot apply the formula directly like this case. So you have to master well for the trigonometric substitution skill as well as substitution skill to solve this problem. Let's try with the example 4. So you can see a very complicated rational function here. So we solve it step by step. First of all, you check the highest degree here is 3. And the highest degree here, be careful, is not 3. Okay, but of 2 here you have to square. Okay, this is x to the power 4 multiply x. Here you get degree, highest degree is 5. So in this case, this is called the proper rational function. So for proper rational function, you check, okay, if we use the substitution, let u equal to x squared plus 1, you differentiate, hardly find the relationship to the top, so we don't apply the substitution. So in this case, we recommend you to apply the partial fraction. So partial fraction, first of all, we have to factorize this. X squared plus 1, you check if we able to further reduce this to linear factor, like x plus a and x plus b. So you should find that this term, okay, your a and b is in complex number, so it cannot be further reduced. So this is the most simplest form, which is quadratic factor. So here you have a quadratic factor, and it's a power of 2, therefore this is repeated quadratic factor, and you have x here, so this is linear factor, right? So we can apply this using the partial fraction, and then you should be able to get something like x plus x squared plus 1. So since this is power of 2, you have to repeat twice x squared plus 1, and don't forget the power of 2. So for linear here, linear x, then you have a constant a. For quadratic, you have linear factor here, let's say bx plus c. So this one is the same, so we have bx plus e. So you have to find the unknown for a to e here. So by solving this a, you should get 1 here. Okay, you can let x equal to 0, you substitute like the method we have used previously, you can get the 1. So substitute x equal to plus 1 and negative 1, okay, you should be able to get another coefficient. So let's say here b you get 1, c you get 1 here. And lastly, here dx plus c, e you should get 1 for the d, e you should get 0. Right? So in this case, I recommend you substitute based on here, you substitute this. X squared plus 1 here is a complex number, so you can put any number and any value. So like this, okay. So to solve this, you need to have additional 2 equations. Let's say you substitute any value, right? So from here you have 4 equations. You solve it, you should be able to get this result. So we can continue. So we can further simplify it by separate the numerator. So this part you can basically solve using basic integration rule, you get the ln x squared plus x. You differentiate, you get 2x here. So this one you can use substitution to get the ln part as well. So x squared plus 1, you differentiate, you get 2x. So you cannot use substitution, where you can see here a squared plus b squared. So for this term, we can use the trigonal substitution, where we let the x equal to, in this case, a squared is 1. So 1 multiplied with tangent angle. Right? So to solve this. And lastly, for this part, we can use the substitution. We let the u equal to x squared plus 1. Right? You differentiate, you get x 2x. There is a relationship. Right? So we continue. If you're familiar with the basic integration rule, these three terms, you directly can apply the formula and get the result. So let's continue with this. So as we mentioned, we can use the substitution to solve this. So we substitute inside. Okay, this part will become u. So your du is equal to du over 2x. So we can substitute this part du over 2x. And therefore your x can be cancelled off. You just get the 1 over 2. So 1 over 2 u squared for this term. You can rewrite this term to be 1 over 2 square root u minus 2 du. So your answer to solve this, you get u minus 1 divided by minus 1. And don't forget multiply with your constant 1 over 2. And you should get this. Let's substitute the u. You should be able to get this result. Right? So with that, we are able to compute all the results. So this one, we get it here, we substitute. And the other three is obtained from